Alright, in the previous video, we created geometry to help rough the slots. Went ahead and created geometry to put the holes in, but we haven't done the holes yet. Created geometry to get to the corners of the slots after doing a ramp toolpath just to get the majority of the meat out of the way. This time we're going to come back and do the holes, and then we're going to finish the slots out. So first thing we want to do is go to our first hole view and go to a toolpath, and we're just going to use a ramp toolpath, ramp tool 2D contour to start this first hole. Use 5/64 end mill. I've got some identified here that are long reach. We're going to do about a 1/4 thou ramp. Not going to leave any stock. 5 thou lead in and out. What we're going to do is just go deep enough to get past this odd area, plus about 30 thousandths to start the hole. So the drill point has somewhere to we get past the drill point on our drill. That looks good enough. We'll do this, go through and do this from both ends on the rest of the holes, and I'll be right back. All right, I've started all the holes from both sides. Went ahead and created a stock model so that we can see, compare what that looks like. So we went just deep enough to catch the outside of our drill so that it doesn't walk off. Now we just got to create the drill tool pass. We left off on this hole, which is in the HB3 view for plane. So we're going to go back to HB3 view, hole back 3. I'll go drill. Pick that arc or the point or whichever one's the center of it. I'll start out with a number 41 drill. This is a 99 thousandths diameter hole. Go down to number 41, 96 thousandths. We're also going to ream these holes. Peck drill, about a 30 thou peck. And leave these just as they are. I think 550 is enough to go to the midpoint. And I'm in, let's do this. Let's go, we're still in 5-axis for our drill points. Because we have a view created for that, for a plane, we don't need to use 5-axis. You can if you want to, you don't have to. Let's just pick the middle of that line, plus some, another 30, and that's about halfway. I'm going to go through and drill, do a tool pass for the drill, just like I just did for all the holes. I'm going to drill halfway from each side, and then I'll come back and show you a quick way for the reamer tool path. All right, got all our holes drilled. Created the stock model just so I can verify that we did drill all the way through from both sides. Now for our reamer, all we got to do is select all these toolpaths since we've already created them. Right click and drag your mouse down, release, and do copy after. All we got to do is go through and change what tool we're using on all of these. So go select library tool. I doubt we've got a reamer that size. We've got a 100 thousandths reamer. What we can do is just modify. Let's go edit 1099. Just change the shank. We're not worried about feeds and speeds right now. I'm just trying to demo the toolpaths. Not worried about tool numbers right now either. That's all over the place, but you're getting an idea of how to create the toolpaths. We're going to go from cut parameters. We're just going to do drill counterbore. Really, we only needed 3 of those. So which way will we be doing that from? That's not the one we needed. We don't want to do, we're going to go from the shorter side, and the reamer's long enough where we can just ream from one direction. So what we're going to do is get rid of the 3 drill cycles from that side. So we can select them, delete them out. Just go in here and change it from drill to the reamer and go counterbore and change our linking parameters to that point. Go to like 1.5. That should be more than enough. Change this. 5 tool. Cut parameters is what I'm looking for. Five. All right, now we've drilled and reamed our holes. It's got a holder associated with it, but we're ignore that right now. We at some point can go back through all this and maybe at the end and kind of figure out what tool holders we want to use and things like that, but we're not concerned with it now. We're just looking at making the tool paths. All right, so we've got our holes drilled and reamed. Now we've got to finish our slots. All right, so the way I've finished these slots, or the way we're going to finish these slots, is we're going to start with a 4mm end mill because it fits in the slot nicely. And what we're going to use is a swarf toolpath. We're going to use this newer swarf milling that's in Mastercam now. So I'm going to go in here and see if I've got any 4mm. See if we got anything with a square corner. Right, let's edit the tool because we're going to need, that's not what I want. So we'll create a tool real quick. Get rid of that. Right, that wasn't exactly what I wanted, so we'll just go ahead and create a tool. Flat end mill. 4mm. And if a lot of you don't know already, here's a quick tip for you. If you just put, if you're using English or inches or whatever, and you want to use convert an easy way to convert from metric to English in Mastercam is just put the number value and then after it and then hit enter, and it'll convert it for you automatically. I don't know how many people know that, but uh, we're going to say this is 2.5 inches long. I can't remember. I think the length of the cut in that ML is about right at an inch. Shows the shoulder length, and that should be good enough. We can say this is 4 millimeters. Again, won't worry about feeds and speeds. All right, so what we want to do is we're going to concentrate on one slot. We're going to pick the walls of what we want to cut. Just like that. And we're going to pick our guide curves. This is going to be, make sure you're in basically this mode of edge mode. So we want individual edges to be selected. And then keep an eye on your red arrow. That's the next direction it'll go in. We're going to go next and go all the way around this top edge. You either hit end chain or OK. Now we want to do the bottom one. We want to keep the edges, our start points need to be close to the same. This version of Swarf Mill will actually work out start and end points pretty well. I think that's the end of that, and it's not too picky about your upper and lower chains being the same number of entities and all that stuff. So for tool axis control, we want 5-axis guide curves. We want to be the Swarf geometries. I think I changed this to like 2/10 for the gouge allowance. And what that's doing is looking at the tool to see if the tool interferes with any of the surfaces as it goes around. Don't think I messed with any of this. Linking we're not concerned with right now. We don't want to do too much at once until we know that our this is the toolpath looks the way we want it to look. So all right, so what we want to do is hit apply. Kind of zoom out where we can see and see if this looks right. And you notice the actual chain it's showing looks kind of funny, but I'll show you in a minute. It actually works out pretty well. So we want to change this because we don't have a lead in and out. So if we go to our linking tab and expand it, we've got a lead in and out. We're going to do this arc sweep. This is fine. Let's do about 15% of our tool diameter. Hit apply, see what that looks like. And it didn't do it. Why is it not doing it? Oh, because we're not telling it to use lead in and out. So we want to tell it to do that for all of these. We're not using this right now, but we will. That looks good. Probably do a little bit more. Let's go up to 25%. All right. And if you want to change where it starts at, you can go, instead of automatic, you can do 2 points. You can, it's basically like we were doing before. We want to create a line. We're just going to do the midpoints of this outer surface. And now it'll start in the middle of this outer surface here. But what we don't want to do is take this all at one time, because there is a little bit of stock left in there. So we're going to go to multi-cuts. All right, you've got slices, and then you've got a pattern. Your pattern is like multi-passes, and your slices is like depth cuts. So let's do 2. We're going to step from top along the tool axis. So that basically, in line with the tool and the surfaces, it'll create 2 depth cuts. And now we're going to do 2 layers of 15 thousandths. So now we're doing 2 depth cuts and 2 multi-passes. If we go ahead and hit OK and backplot this, I think right now it's going to do depth cut first. And then it'll do the second pass. And either one's fine, it doesn't matter. All right. And you can play around with your linking parameters. What we can do, let's change this to the clearance area to a cylinder. Our platter is about 8 inches in diameter, so we're going to use a 4-inch radius. And we'll just leave this automatic. Kind of lessen these rapid distance. Entry feed don't need to be that much, neither does the exit. And then that'll be fine. We're going to change these here, just in case it does do a big move. It smooths out transition. Now we're going to go to our feed rate control, and then we're going to use replace rapid with a high feed, and that should be fine. Don't remember, we don't need this for the clearance, because we're not going to be doing any kind of blend splines or anything. So now that looks pretty good. The next thing we want to do is we can use this one tool path to do all 3 slots basically. So if we go to Utility tab and turn on Transformation and Transform or Translate, we want to change this to Y-axis, because our part is actually, the center line of our part goes through the Y-axis. We're going to change this to 3. And we're going to reselect our base point to be center of any of those diameters. Leave our start angle at 0 and change our rotation angle to 120. And we'll just leave it just like this. And now we've used one tool path to do all 3 slots. And we can backplot this. Why aren't you running? There we go. And the way it'll do it is it'll go through and do the one pass on all of them, and then come back and do the second multi-pass on all of them. And you can change the order in which it does stuff like that too. So that's basically like a semi-finish. And then you can just copy and paste this tool path and do that same thing with the second tool, because you will get a lot of spring on a tool path like this, especially with this diameter of a tool. And so you probably want to run a second tool to be a little bit fresher, and then do like, basically what I would do then was let's just say we copy and paste. All right, so what we can do is duplicate this 3/16 just to show that that'll work. So if we go to our tool manager, click the 3/16, right click, copy tool, paste tool, and it'll say copy of, but we can, like I said, we can go back and edit all this stuff later. So we've got a copy of our source toolpath. Come in here, this one's a copy of. Go to multi-cuts, and let's change this to 0. So we're doing 2 spring passes per depth cut. And we'll leave it at 2 depth cuts because this tool, I'm pretty sure it only has like ½ inch of flutes, or 5/8 of flutes, something like that, which is just enough to do that. And now you've got a spring pass. But we notice, you didn't notice this with this one. See how squared off that is? We can do to kind of clean this up and make it a little bit smoother toolpath. We can go to our cut pattern. Our cut tolerance is at 1/1000. Let's go down to like 2/10. Hit apply. Takes a little bit longer to regenerate. See how nice and smooth that is now? We want to do the same thing on our finish pass also. Otherwise your part will look like what that is. You could also go to your tool axis control and tighten your angles up also. At about 1 degree or 1.5 degrees. Now this does make for a longer program, but most modern controls can fit this stuff. All right, that's got all this stuff, everything programmed. We can do a stop model real quick and see what that looks like. Let's see, don't have the reaming, but we can add that in too. Showing some stuff here, but I think it has to do with the tolerancing of the part, or the tools aren't drawn right or something like that. But this is just a rough how-to on going through something like this. I can we'll come back to, I'll show you an actual the actual program that I've written for this part, and then maybe I'll come back and actually show a video later on of the part machining, because I've actually got deburring in it and all that stuff too. So I think I'm going to end this right here, and then next time I'll probably show a little bit of the actual program, and then I'll actually do a video of the part machining itself. So thanks for watching.